plant at Palatka has its own dock on the St. Johns River. Here on a 1,000-ton barge, the end tow sections of the first two bascule leaves are being reassembled for shipping. A team of specialist ironworkers has been brought in for this high-precision job. The team is led by Vern Nix, who has been hanging steel for 40 years.
We basically do bridge erection all over Florida, North Carolina, and Georgia, and we do hang a lot of steel that PDM fabricates. It's a very hazardous trade. It's pretty risky. You're working high up. Well, you're always dealing with a lot of weight, and so you always have fall hazards and pinch hazards where if you get in the wrong place in the wrong time, you could lose an arm or a finger or a leg, and everything's heavy and it's hot.
Vern's team needs to align the structure to within 1/16 of an inch of its original design.
Our surveyor takes an instrument up top and he sets up on one of those points and he starts shooting the distances and the diagonals and computes all the dimensions and then takes that and compares it against the way it was built in the shop to see if it's in the same position. When they fabricate this in the shop, it's in a controlled climate condition, and when you come out here, it's in a hot sun, and we're on a barge that's kind of floating around. From the last survey results, it shows that we need to move this girder 1/4 inch this way, and the other girder on the far end has to go 1/4 inch the opposite direction. Once we've done that, then we will resurvey the bridge, and if everything's good, then we will tighten all the bolts and be ready for shipment.
Vern's team uses 100-ton jacks to raise and move the girders. By the use of a simple hydraulic hand pump, this massive girder can be realigned with incredible accuracy.
This is another 100-ton jack, and what we've got is another set of jacks down there that's holding this in from moving, and we're going to move this in first. By applying pressure here and releasing that pressure, this whole beam should move back that direction. So Peppy, go ahead and start pumping it up. What we're going to do is we'll build up some pressure. You can't really hardly see it move. It's just in very small increments. Okay, now that he's built up pressure down there on that jack, Robert's going to hold 2 1/8-inch shims in place here, and we're going to push the beam back till it's tight. And in effect, what we've done is we've moved the beam back 1/4 inch. Raphael, bleed the pressure off of that pump.
It's a critical operation, and there's no margin for error. If Vern gets the alignment wrong, it will have a knock-on effect throughout the whole structure, and the bascule sections won't fit when they're lifted into place in Washington.
All right, Peppy, start pumping down there, okay? A little more. Peppy, just a little bit more. All right, hold that right there. Okay, looks good. That's move this beam back 1/4 inch, and now what we're going to go do is on the other end, we've got to move that other beam 1/4 inch that way. And in effect, we've moved the bridge. So then we resurvey, and hopefully it's in the right place.
Back in Washington, time is moving on, and the engineers are anxious to receive the delivery of the barge.
From the date this contract was let, it's probably a month or so behind. The delivery of the barge has a large impact on us in that we've reached a critical stage where that piece has to be here before work can really progress well on the project. So there's a lot of surveying being done down in Florida and alignment of the girders, and also you're now paying attention to the weather. Last thing we want is to put a barge on the water and have a problem at sea.
The shipping of these unique structures is not straightforward. There are major risks involved, and the best route up to Washington is still to be decided. There are two options. One is up the St. Johns River through the city of Jacksonville. Here the barge will pass under an old-fashioned railway bascule bridge, constructed in 1922. From there, it can either travel via the Intercoastal Waterway, a protected channel which runs up the eastern seaboard of the United States. Or the other option is that after Jacksonville, it can go blue water into the Atlantic Ocean. If the barge goes intercoastal waterway, it will have to be pushed by a high tugboat. If it goes into the ocean, it will be pulled behind a powerful, low-bodied tug. The man who has to make that decision is John Hall of the tugboat and barge leasing company, woodrow Marine.
The disadvantage of the inside boat is visibility. The loads are quite high on the barges going to Washington, and it makes it difficult to line yourself up with the bridges, and you're more apt to have an accident by either striking a marker buoy or a bridge. Now, there are no marker buoys or bridges in the ocean, so therefore it takes a lot of the danger out of the equation. The risk is that the ocean is unpredictable. It could get rough enough to dislodge it or even jettison it overboard.
We're always very anxious when a barge pulls away, just because of the different things that we know that can happen to it. We've had situations where barges have run aground because of changing channel conditions, where maybe there was maybe a miscalculation in terms of where the channel was by the tugboat people. We've had barges damaged where they've had to be repaired. So there's a whole host of things that can happen along the journey. This would be a significant disaster. I know that we've insured this barge for $10 million.
The bascule sections have been tied down by naval architect Bill Stewart. Ballast holes will be filled with seawater to stabilize the barge. The calculations for the tie-down have been made on the assumption that the journey will be up the intercoastal waterway, where the precarious load will be more protected from the elements.
The load is very, very concentrated on this barge. It's going in through 8 major points on the deck, and this is way in excess of what the barge has been designed for.
Because the barge is carrying such an unusual structure, the tugboat company is concerned and thinks it's better to take the barge into the ocean. To go safely up the intercoastal waterway would require additional tugboats to help with visibility and steering. This would cost an extra $100,000. To try to resolve the situation, John Hall calls PDM plant manager Jerry Martin.
Jerry Martin, PDM Bridge, Palatka.
Hey Jerry, John Hall up at Woodrow. Just wanted to touch base with you. I guess I need clarification on what we're doing with the Woodrow Wilson barge.
I guess we would like to pursue taking the barge intercoastal using assist throughout the tow.
Tow to do that up there is going to be in excess of $100,000.
Okay.
I guess if the money's not a problem for y'all, it's not for us. I'll just do what I have to do.
Well, you know, obviously money is always an issue with everybody, but if we miss the on-site date of the tow, the liquidated damages per day certainly would exceed any charges that we would have on the assist tow.
There are financial penalties for late delivery of the bascule sections. Jerry Martin has to meet the delivery deadline at all costs, but John Hall favors the ocean route.
The barge, I went down and looked at it the other day, and I measured the vertical limits on it at 29 feet, and the tugboat can't see over that. And so I told them the best thing to do would be to revise the tie-down plan and let us put a tugboat on it to pull it up there.
Redoing the tie-down for the ocean will mean further delays, and the clock is ticking.
What does that do to us? What do we need to do to resolve this issue?
Well, Jerry, I mean, you go out there in the blue water, you're going to have this 20-foot